Hi, in this tutorial we will see how to make a thermoplastic orthosis to stabilize the hand and wrist in a functional position. What we need first is a piece of paper like this and a pen. For the ease of the explanation, I will do this on my left hand. You have first to well position the hand and the wrist so that the forearm is aligned with the middle finger in this way. And the thumb is open in this way. With the pen vertical, you're gonna follow the outer line of the forearm and the hand, and you make sure that you are not going in diagonal way with the pen. So you are not going either inward or outward, because this may change the final dimension of the orthosis. We also make sure to use a small pen so that it doesn't affect the final dimension of the orthosis as well. So we can really follow the hand and give a real representation of the dimension of the hand. Once we made the outer contour, we need to take some reference point. That is, for instance, well, I will first take them and then explain what are these reference points. So there are 6 reference points. The first one that we need to consider, the most important, is the palmar lines of the hand. I'm gonna underline them for the ease of explanation. So these are the 2 palmar lines of the hand. The orthosis should finish below these 2 palmar lines. And this is important because we want the patient to be able to flex the metacarpophalangeal joints up to 90 degrees. If we go with the orthosis too high, this will prevent the patient to flex up to this level, and this may create problem and functional limitations. So we want to make sure that the orthosis finish below these 2 lines. So the first 2 reference points that I took was the end of the 2 palmar lines on both sides. The other reference point that I took was at the level of the wrist, the 2 styloid processes of the ulna and the radio, just to have a reference point that we will see later on why is so important. The last 2 reference points are the end of the orthosis, and we know the orthosis works as a lever with the fulcrum at the level of the wrist. So we want to stabilize the wrist, and we have a distal part and a proximal part, and we want to make sure that the proximal part is about 2/3 in length of the distal part. So about at this point I chose the end of my orthosis so that if it's too long, well, we have a limitation on the other movements such as elbow flexion. If it's too short, we'll give a pressure point at this level. So we want to finish at about this point. Once I get these 6 reference points, I start to design 3 lines that pass through, and I make sure to make long enough yes, this way. Then I start to design what is the midline of each line. Yes, and at this point I will calculate what is the half point of this half line. So this, and this way. Okay. What I have to do now is to report this last half line, which is a quarter of the total line of each reference line, outward. So if it is the quarter, I would report this outward. So, well, this way, this level, so, and the same on the other side. Okay, Then I need to connect, and I'm gonna use another pen just to highlight it. I'm gonna connect the outer points that we just draw, and this will be the outer line of our orthosis. And I make sure I kind of found the follow the shape of my hand and the forearm. Okay. At this point, I want to keep for the moment the thumb free of movement, so I'm gonna have a hole corresponding to the thumb, and I need to find the spot where I will make the hole. To make this, we consider these 4 points, so the midline between the reference line of the palmar lines, the midline at the level of the wrist, and the 2 outer points here. Okay, I make like a big X. So, and here will be the point where I make the hole. So I make a relatively little circle. So, and then I can start cutting with the scissors. So we'll just cut the outer line and the hole here. This way I will have a model in paper of my orthosis. If you dedicate enough attention and time at the initial phase of designing the orthosis, you will save time later on to avoid further adjustments or need to cut and add pieces to the orthosis. So take your time to properly design the orthosis at the beginning. Okay, so then you cut the hole for the thumb. Okay. Can make a little bigger, but not too much big, because the thing is that once you start the modeling the orthosis on the end, this little hole will become really big. So if you start with a big hole, you will terminate for a giant hole. So you want to start with a hole of this dimension, just that the thumb can pass through this way. And you want also to use this kind of paper instead of a normal A4 paper, because you eventually want to try this model on the patient to check if it will be at the right level, the right dimension. So you can also decide to use this paper for this purpose. Okay, once we have this model, we take our thermoplastic material. In this case, I took an Aquaplast black coated 2.4 millimeter thick. This is proper for orthosis that goes bigger than the hand, so at the level as we saw to stabilize the wrist in this case. What we have to do is to position our orthosis to be cut, and we want to do this in a way to save material, as much material as possible, because it's quite expensive. I guess this is the best combination. Yep. And at this point, because it's black, I'm gonna use a white eraser to design the shape. And for the hole as well. Okay, once we have this, we can use another scissor to cut it. I recommend more high quality professional scissor that you use only to cut the thermoplastic material, because it's quite hard to cut, and it's proper to save your hands. Make sure when you cut your orthosis, you make the edges round, because this will be more comfortable to wear for the patient at the end. Now, cutting the hole for the thumb can be really tedious, so I'm gonna use this tool. Don't know the name in English. I guess it's the tool to make holes. And I'm gonna really, dig a couple of holes at the level of the thumb. So that once we have a bit of a space, we can go further with the scissor. Yes. Okay, bigger. If you want to make your hole bigger, make sure that you go a bit upper, because usually there will be a bit of material that exceed here, and you maybe want to flex it and to make sure that you keep free the palmar lines. So don't go never downward, but you can go a bit upward this way. So I want to make it a little bit bigger. Okay. Yep. So this is the final cut of the orthosis prior to to modeling it. What we need now is warm water, and in this case I'm using a thermostatic bath. I'm gonna put this 1 minute in the water, and the property of the thermoplastic material will become soft, and then you can model directly on the patient. So in this case we are talking about a low temperature thermoplastic material that with 60 to 70 degrees Celsius can become soft enough that you can model on the patient. What we need as well is a bit of paper to dry the thermoplastic material out before modeling directly on the patient, because sometimes water is too warm and you have to give a moment. And we're going to use a wide tool such this to take the thermoplastic orthosis out of the water, because if you pinch with your fingers, you're already deforming the orthosis. So you want to use something wide enough such this tool. Okay, should be ready. Yes. So I make sure that I dry it enough, and then I'm gonna model on myself. As you see, I have plenty of time. I can take my time to model. I'm gonna use soft movements to gently adapt the shape of the orthosis to my hand. And I want to put I'm choosing this position because I want to have the forearm midway between pronation and supination. So with the thumb that is facing my face. I can do this because I'm quite enabled to exrotate the hand, the shoulder, and to go in proper position. But if you have a patient that are unable to do so, such as in our case we work with the neurological patients, it's best to put the patient lying on a table and with the effect side downward, and then you can model on the patient lying down like this way on a bed. Okay, you try to go as much an exrotation as possible. If not possible, you can also work at this level, but make sure that you can stabilize as much thing as possible before placing the orthosis, because you want to have both hands free, and you can also ask a colleague to help you out. Use pillows, be creative. The important thing is that you for this orthosis, for instance, that you go in midway between pronation and supination, and that you stabilize the wrist in the desired angle. And as we saw, to keep the palmar lines free so that the patient can freely move all the fingers. And this is it. So this is the end of the first passage. So just to model thermoplastic orthosis, still needs a bit to dry to become strong enough. Now it's still a bit soft, but we can start already to refine the orthosis. So the first passage is that you make the patient wear again the orthosis and to feel whether he feels comfortable, he feels some pressure points. Sometimes we press too much with a finger, and then that could become a problem, pressure point. So we make sure that we want to make sure that everything is okay. We are gonna also check if there are pieces that could be cut, because we want to have like an half cycle as this way. This will provide stability, but we don't want to be more than half a cycle, because this will become difficult to wear in and wear off. So what I see, for instance, is that I could cut a bit more here and a bit more, well, at this point as well. Yes, a little bit. Then I want to know where I will put the velcro straps. So I just well, we know that these 2 points will be for the distal edge and these 2 points for the proximal edge. What we need to know more precisely is where to put the velcro for the wrist. So I just take note of the, yes, from here to there, yeah. So I want the velcro to cover the wrist so that the wrist cannot move this way. If I go too up, if I go to distal, it's gonna irritate the skin at the level of the hand. If I go too proximal, it's gonna give too much freedom. So I've really to go covering the 2 styloid processes of the radio and the ulna. Now that I make these 2 reference points, I need to take out the coating layer that is covering the thermoplastic material. Yeah, I'm gonna use another pair of scissors. As I said, this scissor I keep just to cut the thermoplastic material. Use this one to just scratch all the points where I want to put the velcro. Okay. As velcro, we are going to use 2 loop velcro, one 2.5 centimeter or 1.5 centimeter, and one loop velcro of 5 centimeter. The first thing we need to do is to work with the hook velcro. And we're gonna cut 4 lines. So 2 full lines will be for the wrist. We also, for this velcro, we are gonna make the edges round. And the reason why we scratch the coated material from the thermoplastic layer is that we're gonna hit both this velcro and the thermoplastic orthosis, so that when we attach them, they will stick together and will never, this will be ensured that they are really resistant to be teared up. And I'm going to use this heat gun, so it's just warm air, to heat that. It was up to 350 degrees. Takes a moment. Yeah. Okay. So attach the velcro like this. I'm gonna quickly hit both the orthosis and the velcro, just where I want to attach. And then I really press firmly because I want to this goes very quickly in a matter of seconds, so make sure that you are quick enough not to make the orthosis soft again. Okay, so we go for the second. And I put in correspondence of the reference point that I put at the beginning. Okay. Then, for the other two edges of the orthosis, we'll make a more smaller velcro of about 2.5 centimeters. The reason why we are doing it so differently is that if we consider again the orthosis as a lever and the fulcrum is in the center and there are pressure at the two edges, if there is a pressure of 100% here for the wrist to go into flexion, these are distributed in 50 and 50 at the edges. So I need something large at the level of the wrist and something smaller but yeah, comparable at the level of the other two edges. Okay, so at this point we have 6 hook velcro, 2 for each line, and we need to put the loop velcro. So I'm gonna start with the wrist. As well as I said for all the other parts of the orthosis, we make it round. And this is the first one. Then we go for the second. And finally the last one. So this is almost the final part of the thermoplastic orthosis. What we need still to do is to refine well, the very edges where we cut, because they are quite sharp, and we can do this again with the pistol gun. So I don't have to do it here, because this was the outer layer of the layer of the general layer of the orthosis. I have just to do here few seconds, couple of seconds, just to soften, and then you push outward the edges so they are not sharp anymore, this way. I recommend as well to take your time during this process, because this will ensure that the patient is comfortable with the orthosis. If the patient feels anything like pressure point or scratchy point of something that is not 100% comfortable, is not going to use the orthosis. So you have really to make sure that you address all these problems in advance. And also during the first session, make sure that you ask the patient how he feels about the orthosis. So every time you can always adapt and correct the orthosis, but make sure that you take into account how much the patient feels comfortable. And also personal beliefs of the patient. If the patient believes that he wants it a bit longer or shorter, or believes that he wants the orthosis adapted, that it can be more free or more comfortable, you have to address this. I say that the patient is king, so the patient really has to be taken into account, because if you don't do this, if you just impose the orthosis on the patient, the risk is that the patient is not going to use the orthosis at the end. So make sure you ask the patient how he feels with the orthosis. You have also to make round at the level of the thumb. This is an important point. After. Okay, now the orthosis is ready. And this is the final aspect of hand-wrist orthosis. So at the end we have like a tunnel which is made half from the thermoplastic orthosis and half from the velcro. And this is a rigid tunnel that can put comfortably in a functional position the wrist, but also the hand.